300 years ago, Swiss mathematician Daniel Bernoulli published his work on fluid dynamics, outlining the mathematical relationship between fluid speed and pressure. Today, engineering programs teach his 18th century equations as the historical starting point for our mastery of water flow. But if we travel to Kara di Kulam, a village in the southern Indian state of Tamil Nadu, we find a structure that challenges that exact timeline. 2,000 years before European scientists wrote down the math, indigenous engineers were already putting those exact principles to work. To see how they did it, we have to look below the surface of the local reservoir at a device called the Kumizhi Thumbu. Any artificial water body eventually faces the same engineering crisis, silting. When river water enters a calm lake and slows down, the heavy alluvial soil and mud suspended in that water sink to the bottom. Over the years, that sediment builds up, choking the reservoir and destroying its capacity to hold water. Today, we usually solve this problem through brute force. We deploy massive, diesel-guzzling dredging machines to physically dig the heavy mud out from the lakebed. The Kumizhi Thumbu solves the exact same problem without a single motor. It requires zero energy to run, and the original structure in Karadi-Kulam is still actively clearing mud today. Understanding how it functions requires us to look past our modern reliance on heavy machinery and examine the underlying physics of the reservoir itself. The Kumizhi Thumbu is a specialized stone tub built directly into the lowest point of a reservoir. It relies on two openings. The first, at the top, is the Nirodi Thulai, or water hole. The second sits flush with the reservoir floor, the Serodi Thulai, or mud hole. When the sluice gates are closed and the water is completely still, gravity pulls the heavy sediment straight down. The engineers designed the system so that this accumulating mud acts as a deliberate plug, completely sealing off that bottom hole. By using the silt itself, the very problem it was built to solve, as a mechanical seal, the builders ensured the system was always prepared for its next activation cycle. The entire mechanism sits dormant until the local farmers open the main sluice gate to irrigate their crops. As the valve opens, clear water near the surface rapidly accelerates, rushing violently down into that top water hole. This diagram illustrates the resulting physics. That fast-moving stream creates a sudden low-pressure zone inside the stone tub, while the static water outside maintains a much higher pressure. The intense pressure differential pushes aggressively against the structure's only weak point, the dormant mud plug. The surrounding weight forces the thick mud up through the bottom hole, like squeezing toothpaste, injecting it into the rapid clear flow. With absolutely zero moving parts, the builders created an automatic fluid dynamic vacuum pump. This creates a remarkably elegant ecological loop. Every single time the village draws water for their crops, the reservoir automatically pulls sediment from its deepest point, preventing it from ever silting over. This evacuated mud is a highly concentrated, nutrient-rich topsoil, which the system redirects away from the reservoir floor. The exiting irrigation current catches that soil and acts as an automated delivery network, funneling the mixture straight into the agricultural fields. The exact waste product that would normally destroy a water source is seamlessly transformed into a free, natural fertilizer for the year's harvest. Modern urban planners spend billions trying to engineer closed-loop, zero-waste infrastructure systems that balance human needs with ecological health. The Kumizhi Thumbu proves that indigenous engineers were already using advanced physics to build self-sustaining ecosystems, long before we had the equations to explain how they worked.